Hello everyone, welcome to Edvancer. In this video, we'll be going through third part of Introduction to R. In the previous part, we learned to do operations on objects which contain single data value. But as we progress forward, we realize that objects containing single data values are not enough for doing data analysis. We need some higher data types. By higher data types, I mean objects which can contain multiple values, multiple data values. There are three such kind of data types, higher data types in R: vectors, lists, and data frame. In this particular video, we'll be focusing on vectors. Okay, we'll learn about how to create vectors with the function C. We'll see that with examples. Then we'll see how to access individual or multiple elements which are there in the vector, because vector is going to contain multiple elements. We'll also see how to access with conditions the same elements. After that, we'll learn about some other ways to create vectors. The first way that we'll learn about the function C, which is not very convenient way to create vectors, so to say. So we'll learn about some convenient, handy ways to create vectors using functions or inbuilt operators in R. Okay, let's start. First, we'll start by creating a vector, and as we mentioned, we'll be using function C. So how to create a vector using C? You can, inside the parenthesis in the function C, you can put in all these values separated by a comma. That will create a vector. Remember, using function C, a simple parenthesis like this is not going to work. You'll have to use the function C. So when you run this, you can see here now X contains multiple values. Let's check that using function is.vector. This is a sneak peek for you into a family of functions which are is dot. So it can be is.vector, is.list, is.numeric, is.character, and whatnot. So there is family of functions which return true or false depending upon whether, so in this particular case, is.vector will return true or false depending upon whether X is a vector or not. Okay, so if you run is.vector X, it is a vector. Let's check it on a single value thing, and you will see that is also a vector. Vectors are quite central to our operations. As we move forward, you will realize that. So even single values are considered vector, rather vectors with length 1, a single element. Okay. A special thing about vectors is that they can contain data types of only one type, either numeric or characters. You cannot have a vector which contains mixed data type. Why is that so? Because it makes our operations rather faster, or there are a lot of reasons for that implementation, but we need to know it that it is so. It cannot contain data types mixed. It has to be either numeric or character. And if you look at class of X, it doesn't come out to be vector. It comes out to be as class of the data type which it is containing. So right now, X is numeric because it is containing numeric values. What if you try to force, for example, here we are trying to force that that X should contain multiple data types, mixed data types. When you try to do that, So you can see here these are numbers and we have put in a character value. When you try to do that, R doesn't throw an error, but you can see here all the values have been converted to characters. These numbers are not numbers anymore because they are surrounded by quotes. So these are characters. If you look at class of X, that is also character. Okay, let's go back to our numeric vector. Next we learn about how to access individual elements or multiple elements. Now fine, vector contains multiple values, but if you are going to carry out operations and analysis on these values, you need to know how to access individual or multiple elements. We will be doing that with square brackets. Within the square brackets, you mention the position which you want to access. This is your X. If you say X square brackets 3, you get this, the third value in the vector. So this is how you can extract individual elements from the vector. Now if you pass -3, this is a curious result. If you pass -3, you get everything except the third value. Okay, so this is a way to get a complementary result. X3 gives you the third value, X -3 gives you everything except the third value. Okay, fine. Now how to extract multiple values? This doesn't work. Okay, this doesn't work. It throws an error, incorrect number of dimensions. Now why that particular error? You will understand that when we talk about high data types which have multiple dimensions, but for now we'll just keep in mind that this doesn't work for a vector. Okay, so what we need to do, you need to pass a vector of indices to access multiple elements like this. C1, 2, 5, that will give me first, second and fifth elements. I have stored the result in Z. The resultant will also be a vector because, well, it is containing multiple values. Yeah, even if it was a single value, it still would have been a vector, right? Remember that? Okay. Now few things about these vector of indices which you can pass. They need not be in order. So look at the vector of indices which I'm passing here. They need not be in order. It's not that smaller values should appear first and the larger values should appear last. It's not like that. They need not be unique. You can pass one position multiple times. We'll see what the result is going to be, but first they need not be unique. And last thing is, they need not be always less than the number of elements in the vector. So if you look at X here, it contains 6 elements, right? You can see there are indices 7, or let's make it 10. So you can do that. This will not throw an error. Okay, let's look at the result. First of all, you pass the position 3, so you get at first position of this result the third value, which is 89, then fourth value, so -10, then the second value twice, so you have second value twice. When the position is such that it is larger than the number of elements in vector, you get NA, okay, and so on. So if the value exists, you get that value. If the value doesn't exist, you get NAs. Got it? So this is fine. This is alright. You can pass the vector of indices in whatever way you want. These are not necessary basically. Okay? Just another example. See here? Now, when we put a negative sign in front of a individual index, we got all the values except that one. So x minus 2 will give me all the values except 4. That is the second element, right? So except 4, you have everything here. This was your x. Now, what if I want to exclude multiple values? It's simple. This is your x, and you pass a vector. First, we'll do it like this. You pass a vector of indices which you want to exclude and put a negative sign in front. Okay? Can this work? Instead of putting a negative sign in the vector, in front of the vector, can we put negative elements here? Let us see if that works. That works as well. So you get identical results. What doesn't work, so it doesn't make sense to R if you do this. The error that you get, that mixed negative subscripts cannot be there, meaning and we can also discuss why it doesn't make sense. When you say minus 2 here, you are telling R to give out everything except this, whereas when you put 3 and 4 positive, that means give only these values, which is conflicting, right? So this throws an error. Okay, you can either put a negative sign in front of the vector of indices, or you put negative sign in front of each of these positions, whatever suits you. Okay, but you cannot do this. Now, next thing that we are going to learn about is how to subset vectors based on conditions. Okay, but before that, we need to learn about what happens if we apply a condition on a vector. We remember that when you apply a condition on a single value, result is a true or false. But when you apply a condition on a vector, result is a vector where that particular condition is evaluated on the each value of the vector. So condition is x greater than 4. So it is evaluated on each element. 2 is greater than 4? No, so false. 4 is greater than 4? No, it is equal to, it's not greater than, so false. 89 is greater than 4? Yes, so you get true, and so on. So when you apply a condition on a vector, you get a result as a vector, which basically contains logical values, true and false, depending upon whether that condition got evaluated to true or false for each of the element of the vector. So let's store that in an object. We have named it L. L is a logical vector. Now, instead of numeric indices, if you pass this logical vector in square brackets, notice what you get. This is what L was. See which elements you got as a result. Only those elements have appeared here corresponding logical value for which was true. So 89 corresponding logical value was true. You see that element. 5 corresponding logical value is true. You see that element, and so on. So you get only those values corresponding logical values true, or in other words, wherever that condition is true, only those values are given out. Now, writing the condition, storing it in an object, and passing that object, logical object, as subsetting logical indices vector is a long way to do it. What you could do is pass that condition itself here directly, and that will work too. So I could write x in square brackets, x greater than 4, and I will get all the values from x which satisfy this condition. You can write complex conditions also. So I want only those elements where x is greater than 4 and as well as less than 50. So I get these results. Got it? So you can write directly the condition in square brackets and you will still get the results. Okay. Now, when I wanted to exclude, depending upon explicit numeric indices, I just put a negative sign. But that negative sign doesn't work with logical vectors. Okay. To flip the condition, or rather to get the values which do not follow or do not satisfy the condition, you can get by flipping the condition. So how do you flip the condition or the logical vector is by putting a exclamation sign here, right? So this is your L. When you put an exclamation sign, all the true become false and false become true. You can pass the flipped logical vector and you'll get all the values which do not satisfy this condition. So these are the values which are not greater than 4, right? Of course, instead of passing L, you could write the condition directly, right? And it'll get you the same result. Just remember, to flip the condition, you put a exclamation sign at the beginning. Okay? Right? So these are a few examples wherein you can write many kinds of conditions and you get the result. Okay? So these are the examples that you can try on your own. Now, when you want to create a vector, the one way we have learned is using the C function, which is not very convenient. Let's say I wanted to, create something like this, vector containing values from 23 up till 100. Now, that will be a very cumbersome, inconvenience causing way to write 23, 24, 24 up until 100. There must be a better way to do it, and there is. That is using A:B. How does that work? When you write 2:10, look at X. It's simply a vector which goes from 2 up until 10. What it does, it basically creates a sequence of integers starting at 2, finishing at 10 with increment of 1. Depending upon whether you're going up or down, R automatically considers increment or decrement, but that will be of unit 1 only. Okay, I'll show you some examples. So when you write -3:-1, so this goes from -3 to -1 by increasing value by 1. When you write -3, 4, again from low to higher, it will go from -3 to 4 by increasing 1. So -3, -2, -1 up until 4. But when you write 4:-2, that is, you're going from high to low, it will automatically decrement by 1 like this. Okay. Now sometimes I do not want just a sequence which increases or decreases by 1. You might want to supply custom values of increment or decrement. That is, you can achieve with using function seq. Okay, that is short for sequence. So argument there are from 1 to 5. By is the increment or decrement which you want to specify. Let's look at the result. So you can see here it starts at 1, then 1.7, that is the increment you have specified, and then 2.4, basically you're increasing by that value, and you stop at 4.5. 5 is not part of the sequence because, well, it doesn't fit in there. So when you use by argument, you'll get the sequence will start at here at this point. This will always be there, and then it starts to apply that increment. It keeps on increasing the value until the value is either equal to this or less than this. The moment value goes beyond, that value is excluded and the sequence stops there. Okay. Keep in mind that this increment should make sense. So right now I have put in minus 0.7. Well, it is not possible to reach to 5 or less starting from 1 and using increment of minus 0.7. So you will get an error like this. But in this case it makes sense and you'll get the result, right? Now sometimes you don't want to specify increment or decrement. You just want that, you know what, give me a sequence from 1 to 10 which contains 13 elements. So you can use the argument length. Go from 1 up until 10 which contains 13 elements. So R on its own figures out what the increment or decrement is supposed to be. It will start at 1, end at 10. So both the elements will be included, and in between it will add 11 more elements to make a sequence of 13 elements. In this case, R has figured out that increment is supposed to be 0.75. Okay. So it's your choice. You want to specify the increment, decrement, or you want to specify number of elements. R works both ways. Okay. The last method that we want to talk about today to create vectors is rep, which is short for repetitions. It creates vectors by repeating values. So this will repeat 2 10 times. This will repeat character A 5 times, right? It works like that. You're not bound to repeat single values. You can repeat vectors also. So we are going to repeat this numeric vector 4 times. And this is the result, 156, 156 repeated 4 times. Similarly this, AB, AB, AB repeated 20 times. Now, by default, when you write it like this, you can look at the result. Let me clear this. Okay. Look at the result, AB, AB repeated 4 times. But you can also use the argument each. So when you say each equal to 4, you get the vector of the same length, but the way things are being repeated, that changes. So now instead of repeating the entire vector again and again, the individual values are repeated these many times. Each individual values are repeated these many times. So A is repeated 4 times, B is repeated 4 times. Okay, so these were few handy ways of creating vectors, either to test your algorithms or just to, test your functions and so on. Okay, much better than simply using function C. We'll stop here for this video. Until next video, bye-bye.